Welcome to another episode of the More You Know Show. Today's topic is electrochemistry, with a focus on the voltaic cell. First, let's talk about electrochemical cells in general. There are two types of electrochemical cells: voltaic cells, sometimes called galvanic cells, and electrolytic cells. An electrolytic cell transforms electrical energy into chemical energy, while a voltaic cell does the exact opposite. In an electrolytic cell, an external electric current is applied to drive a reaction. In other words, the chemical reaction in an electrolytic cell will not occur spontaneously. On the other hand, in a voltaic cell, the chemical energy is transformed into electric current without external help, a spontaneous reaction. One or more voltaic cells are used in the batteries of the electronic devices that we use every day, such as the batteries in your flashlight, car, and even your MP3 player. The voltaic cell is important for everyday life, and for that reason, we will be focusing on it. Now, let's go over the parts of the voltaic cell. Here we have an overview of a zinc-copper voltaic cell. A simple voltaic cell consists of two half cells, each of which contains a piece of metal, known as an electrode, that is submerged in a salt solution of the same metal, known as an electrolyte. A copper-zinc voltaic cell, as its name implies, uses copper and zinc as electrodes, and a copper sulfate and zinc sulfate solutions as electrolytes. There is also a metal wire connecting the two electrodes and a salt bridge connecting the two electrolytes.
Thanks for all of that information. Before we go into more detail about the different parts of a voltaic cell, we need to understand the concepts of oxidation and reduction. A voltaic cell produces electricity through an oxidation-reduction reaction, or redox reaction. A redox reaction is a chemical reaction in which electrons are transferred from one element to another. Oxidation occurs when a molecule, atom, or ion loses electrons, while reduction occurs when a molecule, atom, or ion gains electrons. In a voltaic cell, the place where oxidation occurs is known as the anode. You can remember this easily with the following mnemonic device: an ox, anode, oxidation. In the zinc-copper cell, the zinc bar is the anode. On the other hand, the place where reduction happens, the gaining of electrons, is known as the cathode. In the zinc-copper cell, the copper bar is the cathode. You can remember this by red cat. Let's head over to Carolyn so we can learn more about the voltaic cell and how it results in the flow of electricity.
Well, as Emily said, a redox reaction is a chemical reaction in which electrons are transferred from one element to another. In a voltaic cell, we have electrons flowing from the anode, which is negatively charged, to the cathode, which has a positive charge. This flow of electrons from anode to cathode through the metal wire produces an electric current, which can be used to power a variety of things. Now you might be wondering what the purpose of the salt bridge is. To explain this, let's head to Lily.
Thanks, Carolyn. The salt bridge is an essential part of any voltaic cell. It keeps the electrolyte solution of each half cell electrically neutral by allowing the free flow of ions from one side to the other without reacting with the cathode or anode. Without the salt bridge, positive and negative charges would build up around the electrodes, causing the reaction to stop. There are two types of salt bridges. One type is made up of a porous substance, such as filter paper or even a paper towel, soaked in a relatively inert electrolyte. The second type consists of a U-shaped glass tube, again filled with a relatively inert electrolyte solution. Porous materials and inert electrolyte solutions are used because you only want a flow of ions to balance charge buildup, without interfering with the flow of electrons through the wire or the redox reaction itself. Recall that electrons flow out of the anode during the redox reaction. When this happens, cations, or positively charged ions, are dissolved in the electrolyte solution. In order to balance this charge buildup, anions, or negatively charged ions, from the salt bridge flow into the anode side. At the same time, cations from the salt bridge flow into the cathode solution to balance out the buildup of anions, which results when the cations in the solution are reduced. With the charges balanced, electrons can keep flowing, and the redox reaction can continue.
Now that you understand how each part of a voltaic cell works, we will build our own simple voltaic cell and show how it can be used to produce electricity. We will need 4 lemons cut in half, alligator clips, zinc nails, and a copper penny. First, I will insert the nail and penny into the lemon. The zinc is the anode, the site of oxidation, and is negatively charged, while the copper is the cathode, the site of reduction, and is positively charged. Now I will connect the pennies to the nails using the alligator clips. You may be wondering where the salt bridge is in this improvised voltaic cell. Well, the lemon itself plays the part of the salt bridge. It allows for the ions to flow freely without reacting with the zinc or the copper. Now, let's see how many volts we get. Success! Thanks for watching The More You Know Show.
The more you know, the better it is.